What's up? What is going on, fellas? So, man, it's the usual Monday. Just got back from work. We were gonna have a little bit of a different show, but because things got a little strange right towards the end, we are gonna go with my original plan, which is to talk tonight about some nerdy stuff. What is going on? We got RC rolling. We got Mike SSI in the house tonight. Dave in Kentucky, KBRC. David Snyder, hope you're feeling better, buddy. Michael Wrightside, Ken Sprouse, Wild Bill. What's up, man? There's BitGo Hobby. What's up, Bobby? BitGo Bobby. Paul McNeil, what's happening? We got Pilot Jerry. All the usual suspects. If there's anybody new watching, don't be afraid to chime in the chat. Rich M, how you doing? Shadow Ops, good to see you. So, oh, and now we got a cat. Rodeo Pilot, what is up? So Cat wants to come up here and check out the business. Love on some 3D printers and hang out and chill with us for the evening. That's right. It's his table, it's his 3D printers. He owns the place, we're just guests. We are just guests in the cat house. So it's good to see everybody tonight. So as you may suspect, tonight we're going to be doing a little nerdy talk about 3D printing and kind of the different applications of the two different types of 3D printers that we see here. And, you know, the types of parts that we would make with something like a Creality Ender 3 that we see here, or an Anycubic Photon that we see here. So the different types of printers, what we can do with them, the different types of medium that they use, because they're way different. You know, even though the concepts are similar between FDM and SLA printing, they are way different in the way that they do things and the way that we have to, you know, process the prints once they're finished. But the cat just wants to be in the show tonight. So how's everybody doing? I hope everybody had a great weekend and that y'all are ready to you know, start the week off with a little bit of Air Marshal Monday, episode number 66. So I see y'all talking with BitGo Bobby. Don't forget, if you're looking for BitGo products, to hit up the RC Air Marshal affiliate link. You can get to that by going to rcairmarshal.com and click on that BitGo Hobby icon. That'll take you over to BitGo Hobby. You can buy whatever you need. It pays a small commission back to the channel every time you buy something, and that is one of the biggest ways that you can support the channel. You can also check out any of our other affiliate partners at rcairmarshal.com, including our merch store at Teespring, or just Spring now, I think is what they call it. I may have to change the URL. It might be broken. But yeah, hit us up on our merch store. Hit us up at BitGo Hobby. Hit us up at Horizon. Hit us up at Amazon, Banggood. You can hit us up with a PayPal link, a PayPal donation. So, you know, for those of you that were wondering, you know, maybe like why I removed the PayPal donation link and all that stuff from the descriptions of the videos, all of that is at rcairmarshal.com now. So you don't have to like go down to the video description anymore. And it's a little easier to get away with that stuff because it might not be, it might not be 100%, according to YouTube policy for me to freely advertise like, hey, you can make donations to PayPal. PayPal loves super chats or YouTube loves super chats, but YouTube also takes 30%. All right. So we'll just talk the talk a little bit. Any suggestions for a cockpit for Orion STA? Are you looking for like the entire, the entire like cockpit area or just an instrument panel? It's cool, Shadow. See, Mafia, what is up? Oh, so if you're looking for like the whole bucket, the whole like cockpit area, the place I've always had the best luck looking for stuff is, and you may or may not be familiar with it. It is a website called Thingiverse. Thingiverse has all kinds of weird stuff. I'm always shocked when I go to Thingiverse and I search for whatever I'm looking for. You can usually find it. So if you look for the seat and side panels on Thingiverse and see if they got it. Okay, so you've checked that already and they didn't have nothing? John Graham, no Calvin stickers tonight. That is a whole different subject. Cutting vinyl is a whole different subject. But also fun. So we may do that at another time, go through the process of how I make custom vinyl stickers. And the machines that I use to cut them, the type of vinyl that I use, etc. It's not a super long process. Bobby, I do not, right? Any stickers that I have will be, what's up, Hamilton Tiger? Dave Air Marshal Hell is about right. That's what I'm living in right now, man. I didn't even have time to clean off the workbench tonight, man. I've got like pieces and parts of Mustang just shoved off to the side. I've got like a stabilizer that I got to put some carbon reinforcement in because this thing is a little bit wobbly. Can't have that for the racer Stang. And those of y'all who watch my Instagram, if you don't watch my Instagram, check it out at the RC Air Marshal on Instagram. You guys have probably seen this big beast. This is the spinner and 1010 propeller that is getting strapped to the front of a 1200 millimeter Dynam Mustang. This motor is beefcake. This is huge, dude. Huge. So, follow my Instagram so you guys can see, how I'm progressing on the Mustang. We've got the nose chopped off, split apart, and this is going to get grafted into the nose of the Mustang. I've got some plywood that I'm going to be making a new firewall that this will mount to. We're making some ventilation ducts to port air onto the motor, and we're going to have this thing tucked right up against the foam at the right incidence angle, so the right thrust angle, down and to the right to hopefully mitigate the plane from just rolling under too much power. But we'll see. we'll see how it goes. I think this thing is going to be insano fun. and we're just, at the end of the day, I hope it's just a bunch of laughs. But I really want this plane to fly. I think if we can get it in the air and we can get it airworthy and tame the torque roll down from having so much freaking power, that this thing is going to be awesome. And, you know, the old saying as it goes is to finish first you must finish. So I'm trying to make an airplane that is going to hold up with this much power on it. Under 6S power, it's an 800 kV motor with a 1010 prop. I mean, this thing is going to be... I mean, the power system came from a V1200, and we all know how fast a V1200 is, right? So I am trying to... That's awesome, Rich M. You know, I'm looking forward to see that one also. He's got a much faster motor than I do, but I'm afraid that his, I mean, we'll see how it works out, right? He's using an EDF motor, which is a direction that I was kind of looking at. I've got this V1200 motor. I mean, we'll see how they compare. I don't know that the EDF motor is going to be able to turn its full RPMs without just pulling a massive amount of current. So, you know, the wattage that an EDF motor is able to take is a lot lower than like a big fat outrunner. So, you know, it'll be interesting to see how that pans out, and I hope it works. I hope it works out well for you. But that I was afraid of pulling too much wattage through an outrunner that was made for EDFs, or even an EDF in-runner. You know, trying to throw around a big prop with one of those things, I think is going to put too much torque on it and make it heat up and fry. So we'll see how it works out. I hope that it works well and you guys are able to hit like ridiculous speeds. Mickey B, what's up? Sorry, Amy's not here. So the dogs are like fighting with the cat. It's what happens when Amy's not around. If you hear the dogs barking, I got nothing. JCB67, that is correct. There is nothing stock about these stock aircraft. Yep, the UMX Dobermans are in the house. All right. Y'all ready for a UMX Doberman appearance? We'll get a quick UMX Doberman appearance, and then... and then we'll talk about some 3D printing. Yeah. He's all upset because he just got molested by the cat. You gonna look at the camera? Nope. He's like, just smack my butt. All right. So Kenny was saying, make us something. Unfortunately, neither one of these are plugged in. So, and for those of you that are familiar enough with 3D printing, you will know that that is not a short process, right? So we have 2 hours, you know, to blow through as many topics as we can. And 2 hours is typically not enough unless we were to have started the build process like immediately. You know, only like the smallest prints are going to print inside of a 2 hour window. So we're not going to be making anything tonight, but we're going to be talking about these two printers and, you know, some of the differences between them, some of the similarities, and what the different applications are for each one. So thank you, Ken Sprouse. I appreciate it. Ghost RC George Pryor, good to see you. So 3D printing doesn't necessarily have to be expensive. FDM printers, and for that matter, even the SLA printers like we have over here, the FDM printers you can get for right around $200 now. And there's a lot of great applications for FDM printers. Pickle Pilot, how you doing? So let's first talk about this, right? Because the FDM printer, this is probably what more people are familiar with. You know, people that think 3D printers, this is usually like if you visualize in your head what a 3D printer is, this is typically what people are thinking about. You know, you've got your gantry, you've got your hot end, with like a carriage, your extruder. This one is a Bowden style, or you can have direct drive where the extruder sits directly on top of the hot end. This is a artesian style printer, which means that the bed, which is your y-axis, moves back and forth, and you can see if I move it fast enough, it charges up the capacitors, with the stepper motors, and will light up the screen. That's pretty cool. So the y-axis, the bed moves back and forth for the y-axis. The hot end which is your x-axis, moves back and forth on the gantry. And you've got a z-axis motor, like a worm drive motor, that raises that gantry up and down, right, to control our z-axis. So as we lay down plastic, as we lay down that first layer of plastic, it will move up. The stepper motor on the z-axis will move up to facilitate the next layer, and then it starts laying down more plastic. And the way that these work is they've got a nozzle. I think the fairly typical default nozzle that you get on a 1.75 millimeter filament printer, which this uses 1.75 millimeter round filament in different formulations. So you can get PLA, which is like a very hard, not very thermal resistant print material or plastic material. You can print in ABS, which is a little more difficult to print. It warps, especially with temperature fluctuations. So it's better to have like an enclosed printer for ABS. You can use PETG. You can use TPU, which is a flexible filament that doesn't necessarily work well in a Bowden tube style printer like this one. Works much better in a direct drive printer where the extruder sits directly on top of the hot end. So, but the idea is that there's typically either a brass or a steel nozzle that looks like the end of a hot glue gun. So effectively what we're doing is we're taking that filament, which just looks, it's on a roll. In fact, let me go grab a roll of filament. All right, so here I've got a roll, this is PETG filament, and PETG, it's got better temperature handling, it's a little more flexible than PLA, so there's applications for all of the different filament types, depending on what you need and what you're making, what you want to do with it. PETG is not supposed to harbor bacteria and things like that. It's not supposed to like have bacteria growth, or it's easy to sterilize or whatever. I mean, I don't consider anything 3D printed to be food safe, but, you know, PETG is the most food safe of them all. If you're going to make like a cup or something, I wouldn't drink out of it if I were you, but hey, to each their own. Oh, thanks, Kenny. Yeah, I'm trying not to blow another sneeze out of my ear. That would be terrible, terrible. That was some bad pain. So, this is what the filament looks like, and basically, you know, it comes off of here. It's just rolled up on this thing, and it's a little line. Let's use our fancy people trick, and we're gonna zoom way in because this stuff is really thin. It is 1.75 millimeters in diameter. The filament is, and you pass this filament through the Bowden tube and out the hot end. So effectively, what is happening is you're taking this filament just like a hot glue stick in a hot glue gun, and this thing is melting the filament, melting the plastic, the extruded plastic, and applying it to the build plate. Right, so the build plate on this particular printer is down here at the bottom, and it will move the X and Y, you know, so as it moves around, it can make circles, it can do whatever. And then when it's done printing that first layer, it will move up and print the second layer on top of the first, right? So it's what's called additive manufacturing, right? We're adding material as we go, which is completely the opposite of subtractive manufacturing, where we're removing materials. So like a mill or a lathe or something like that would be a subtractive manufacturing method, where this is an additive manufacturing method, right? So this style of printer, we're squeezing out plastic filament through a little 0.4 millimeter brass nozzle that squeezes out a fine line of that filament, and it, you know, different patterns and things like that. I mean, they're pretty fascinating to watch. And I have caught myself like watching an entire print that took like 3 hours, just sitting there and just fascinated at how it worked. So I said 3D print weed eater line. I mean, it comes on the roll, like ready to go for a weed eater. Mr. Tughill, how are you tonight? Good to see you. What is up, Raymond Molina, George Watts? There's some new folks in here, and I've just been blabbing, not paying attention. So I do apologize. I'm not trying to ignore everybody. All right, so that's kind of the basics of an FDM printer, how they work, you know, what do they do, you know. So there's a lot of folks that are in the RC community that either have 3D printers or they want 3D printers. And I think that a lot of people get intimidated by how complex is it, how difficult is it to set up. And what I'll tell you is they can be tricky to get them printing right, but once you get it right, they print beautiful. You get very good results. You know, the issue with FDM printers, and the reason that we have both an FDM, you know, like the hot end, the extruder, melting the plastic, all that stuff. The reason that we have an FDM printer here and an SLA or a resin printer is because they're for two totally different types of applications. William, this is a Creality Ender 3. This is arguably one of the more popular kind of entry level FDM printers on the market. So very popular even today. Now that this is the original Ender 3. I've had this thing for a few years now. They also make the Ender 3 Pro, which has a few upgrades that this one does not have. And now they have the Ender 3 version 2, which have even more upgrades that this one doesn't have. Like the Ender 3 version 2 has a better control board. It's got a touchscreen panel instead of like the, like monochromatic LCD that this one has. Better power supply, more, this one's a 24 volt power supply, but I think that one has a higher current rating. The Ender 3 V2 is fantastic. So I would, if you're interested in one of these, I would be looking at the Ender 3 V2. And if you don't mind, go to rcairmarshal.com and clicking the Amazon link. If you're going to buy one from Amazon, use my link to grab a printer. Helps us out a little bit. If the V2 is not touchscreen, it at least has a more, I don't know, it's a different type of screen than what this one has. It may still be like a scroll wheel, but it's a more graphical interface, where this one is very much like text. Yep, I haven't actually seen one of the Ender 3 V2s in person. I've just handled them, just what I see on the internet, right? And I haven't really looked at the reviews because I'm pretty happy with the one I got. And this one has enough like upgrades and stuff done to it that until it craps out, I have very little doubt that it performs every bit as good as the Ender 3 Pro or the Ender 3 V2. So until I find a necessity to upgrade this thing, I'm not gonna. What up, Ryan? Jermaine Spencer, how you doing? It is good to see everybody tonight, man. Welcome to Air Marshal Monday. David, yourself, how is it going? All right, so the setup on these, there is a calibration process that you kind of need to do. I know plenty of people that have never done the calibration process, and they wonder, like, why. Like, you can level the bed and you can get all that, but the thing is, like, none of these things are perfect. They're all made in China. A lot of them, the beds are warped. So even though you level the beds on the four corners, the bed in the center may have a little dip, and it may not be that noticeable, but there may be a little dip. So, like on this one, it's not sitting on there right now, but I use a glass bed, so that tempered glass bed is almost guaranteed to be nice and flat, so you can almost reassure yourself if you're using, a glass bed, that when you level the bed on those four corners, that you're pretty good to go, and you're going to get a much better first layer, because like these things are absolutely dependent on that first layer being perfect. If the first layer doesn't stick to the bed, if you don't have good bed adhesion and you don't have a good first layer, the rest of the print is just going to be garbage. And if it doesn't grab a hold of the print bed, not only is it going to be garbage, but as this print head is moving around and the bed's moving and all that stuff, eventually that print is going to detach itself from the build plate, and it'll just start moving around with the print head. And as this continues to go up, and you can ask like Jermaine Spencer, anybody that's got an FDM 3D printer will tell you that they have had at least one, if not many, spaghetti incidents where they've got like, your print will start and it'll look great, and then you'll walk away and then you'll come back like an hour later and you've just got like globs of print filament, you know, squeezing out of your nozzle, and you just made a huge mess and the print is ruined, right? And then you have to like abort the print, start over, re-level your bed, do all kinds of crazy stuff, you know. So there's a lot of, I won't call them headaches, but you know, there's a learning curve. And once you get this thing dialed in, you know, so I always refer back, because every few months I'll go back and recalibrate everything. And there's a specific video on a YouTube channel called Teaching Tech that goes through the calibration process specifically for the Ender 3, but it'll work on any of the FDM style printers. I go and watch the Teaching Tech calibration process. It works great for the Ender 3s. It works great for like the Anycubic. Anycubic makes a 3D printer that looks almost identical to this. It works for the monoprice printers. It works for like the Taz printers. It'll work for any of these. It'll work for the fancy ones, the Prusas. You know, there's a lot of FDM style printers, and that calibration process will work for all of them. And it goes through and it has you like do a filament run out test. It has you do temperature testing, stringing testing, calibrating the dimensions, like how much it's moving, calibrating the extruder steps. And once you get all that worked out, I mean, your parts are going to come out great every time. You know, and where you start running into limitations with an FDM printer is, unless you go with a really small nozzle, and like the smallest nozzle I've seen is like a 0.1 millimeter, but a 0.1 millimeter nozzle is almost impossible to print from. You know, because you have to heat it up more and you have to feed the filament in a lot slower. And I mean, the plastic that comes out of there is like a hair. And it's very difficult to get that nozzle, to get the plastic to adhere to the print bed. You know, typically people don't go down from 0.4 millimeters. They go up, you know, to like a 1 millimeter nozzle. Or like a 1.2 millimeter nozzle, which still requires, you know, more heat and a faster extrusion rate because you're spitting out more stuff. You know, you're spitting out more filament through the nozzle. But you're able to print faster, right? So you can have larger layers. You know, and that kind of gets, again, to some of the deficiencies or some of the, not necessarily flaws, but limitations of FDM printing is, you know, the layer lines are noticeable. They're visibly noticeable. You can see them. They're there. You know, so for even the best 3D printers, you can tell that you're looking at a 3D printed part from a ways away. You know, you're going to see those layer lines and you're going to be able to feel them, you know. So when you put your hand across, you know, that printed part, I don't know if you guys can hear that, but you can feel the layer lines. They're not perfect, right? But they get the job done? Absolutely. And there are ways, you know, to get around that. You can use filler primer, you know, spray a filler primer over it, sand it. You can do a lot of post-processing to make an FDM printed part look awesome. You know, very smooth textures. You can sand them. I mean, there's a lot that you can do with an FDM printed part at the end. You know, the issue that I run into is I have been, you know, printing smaller and smaller parts and wanting more and more detail in return, right? So as you can imagine, an FDM printer does a great job the bigger the object is, you know, because the layer lines are not as noticeable the larger the object gets. The smaller the object gets that you're trying to 3D print, you can't really smash those layer lines any smaller. You're still looking at like a 0.2 millimeter layer at best. So when you're printing at 0.2 millimeter layers, and those layer lines, so every millimeter there's 5 layer lines. Everything becomes much more noticeable. And with a smaller print, you got less layers to work with, so there's less resolution in that print. And what I found is that I want to, start printing smaller items that I don't want to have some of the imperfections that would be associated with trying to print a small part with an FDM printer. So what I've done is I moved over to SLA printing, or printing with resin. So the resin printing process is way different. We're not squeezing plastic out of a filament. We are, so first let's talk about the resin itself, right? So the resin comes in a bottle. You can either get like 500 milliliter or 1 liter bottles of resins that you can use. And as with any other type of resin, so Mickey B's got a question here, and it says, with PLA, I've heard of people using an acetone bath. Yeah. So the acetone vapor does, can smooth out the surface, depending on the type of filament that you're using. So I have heard of that as well. It doesn't work on every different manufacturer's PLA. There are specific PLAs that, or I won't say specific ones, but there are PLAs that react better to the acetone vapor than others, which do help with smoothing out the layer lines, but at the same time, it diminishes some of the detail of the print. Effectively you're melting the layer lines by using an acetone vapor, chamber, which, there's trade-offs to it. Depending on what you're printing and what your intended results are, it may not give you, even though it'll be smooth and the layer lines will go away, you may still not get the desired effect that you're going for with the print. So with SLA printing, it's a completely different type of material. So I'm sure that some of you guys that you've worked with epoxies, you've worked with fiberglass resins, or not, but typically, you're going to have like a 2-part system where you mix part A and part B in equal parts, or sometimes unequal parts, and you mix that all together, and it will get hard over time, right? So the hardening time is usually based on how much hardener you add to the resin. So with epoxy, you've got like an epoxy resin, and then you've got a hardener. You mix them together, you stir them up, you apply it to whatever, and after the cure time, and it just takes time because it's a thermo-based epoxy. So it'll get hot, it'll create a chemical reaction, it'll cause the epoxy resin to harden, to turn into a brick. Epoxies get hard. And so do these resin prints. Now, the way that these resin printers work is they use a liquid resin that you pour into what's called a resin vat. It's a small tray, right, that sits over an LCD screen. On this particular printer, the LCD screen is a 2K, so half of, they make one out there right now that I know of that has 4K resolution. But this one has 2K resolution on like a 6.1 inch screen. So it's a much smaller build volume than you would get from an FDM printer. So that's one of the drawbacks of these SLA printers is you've got a much smaller build volume. But if I want a larger part than can fit on this printer, I'm probably okay with printing it on an FDM, which is why, you know, it kind of plays into having one of each. So with these printers, the way that they work is the resin, instead of being cured by, you know, by a hardener, by a chemical reaction, it is cured with ultraviolet light. So you apply ultraviolet light to the resin and it hardens that resin. You know, kind of like the bonding material that the dentist will use in your mouth or whatever. You know, they'll use these new like resin-based fillings instead of the old mercury or whatever that they were putting into our mouths for years. You know, they'll use like a resin material and then they'll shine an ultraviolet light on it and cure it. And that's how this works, right? So that liquid, you know, goes into what they're calling a vat. You know, it's a little rectangular tub with a clear piece of plastic on the bottom. You set that over the screen, and the screen has 4K resolution, or in this case, 2K resolution. Every pixel of that screen would typically be black. So it's monochromatic. It's a monochrome setup. So the pixel's either on or off, right? It's either black or it's not. And, you know, with a white light, you would see either white or black or varying shades of gray, depending on how much of the black you actuated, right? So the way that this works is the white pixels will allow the UV light that is underneath the screen to shine through and cure the resin in that one tiny pixel. So if you think about like the size of a pixel on a 6-inch screen, you know, we're talking like 300 and some odd pixels per inch. You know, for every square inch, there's hundreds and hundreds and hundreds of pixels, right? So you've got much, much finer resolution than you do using an FDM printer. The other thing that's really cool about these is that every layer, no matter how many of the pixels you are exposing to the UV light, every layer takes the exact same amount of time, right? Because once you expose the UV light, so say you have 5,000 of these pixels that are allowing the UV light to come up through the bottom and cure that resin, all of those pixels are basically allowing the light to come through all at the same time, right? And there's an even amount of light coming up. So every layer has a consistent time, no matter how much material you're curing, which is also very different from, you know, from an FDM printer. It has to lay down that first layer one line at a time, you know, so it's a very lengthy process, where for the same print over here, every layer takes like 2 seconds, you know, so it exposes it to UV light for 2 seconds, and then that will adhere to the build plate and it lifts it up, sets it back down, 2 more seconds, lifts it up, sets it back down, 2 more seconds. So like every 4 to 5 seconds, you're printing another layer, right? You're adding another layer to it. Now the real difference is the layers are so much smaller on an SLA printer that you really don't see the benefit of the speed of every layer getting done in like 2 seconds that you do on an FDM printer. Like the FDM printer, sure, it takes a while, but you're getting like a 0.2, 0.3 millimeter line, you know, layer. Here, your layers are like 0.03. So the layers are 10 times the size. 0.02, 0.03, 0.05. You know, they're microns in size. You know, where like they're tiny, very fine layers. You know, does it still have layer lines? Yes. Are they visible to the naked eye from like a foot away? Not anymore. You got to get up close and personal with the prints that come out of an SLA printer in order to see the layer lines. The prints come out with such fine detail. I mean, there are guys making little miniature statues that are like 1.5 inches, 2 inches tall, you know, to play on their little gaming sets. John Nunes, what's up? I appreciate it, buddy. And the Mars looks pretty good. So John Nunes is saying that he's got the Elegoo Mars, which is cool. Yeah, and Mickey B was saying photochemical reaction. That's exactly what these things use. And, you know, the nice part about this, though, is that the level of detail that you can get and the size of the prints, I can make tiny, tiny objects and have them come out with the type of resolution that you would expect to see on like an iPhone. You know, like, I mean, fine details. Awesome, you know, text rendering, awesome detail. You know, the prints come out amazing on an SLA printer. Between, you know, like FDM and SLA, SLA spanks the crap out of FDM for fine detail. The FDM prints are typically stronger. You've got a wider range of materials to work with. You know, if you're not printing little figurines, if you're printing, you know, like, so here I've got a little case that I've been working on, you know, and I 3D printed this little case using the Ender 3, and this holds like my little Rode microphones. So my Rode Wireless Go units just pop right in there. And, you know, it's been fantastic. I just pop those in there and it works great. So an FDM printer is better suited for something like this because this is going to go like in my bag and I need it to have some strength to it. I don't necessarily want it to be brittle. And like I was saying, with an FDM printer, I mean, you can almost take this thing off the build plate and start using it right away. If you don't care about the layer lines, if you just want something practical, you know, I've got this like in a little box, and down here I've got little compartments for the USB cables and stuff like that. You know, if all you need is something practical like this, and you're not worried about so much the looks and the fact that there are layer lines that are visible, you can take this straight off the printer, throw your parts in, throw it in your bag, and be done, right? That's not how it works with an SLA printer. So remember, we're working with UV light and resin that does not cure until it is exposed to UV light. Well, in the printing world, you know, you don't want to leave the exposure on too long because you can overexpose it, which will burn the print. You know, it kind of makes sense. So in order to get the detail levels the right way, I mean, you have to find that balance between, you know, kind of like when you're taking a picture with a camera, you know, you don't want it to be underexposed because not enough light will get in. You don't want it to be overexposed because you'll have like a bunch of light blowout and it'll basically burn the film. You know, when we're talking like old school film, you want the exposure to be just right to allow, you know, just enough light in to get you the image that you're looking for, right? So the same thing kind of holds true here. You want the exposure to be enough to cure the resin to make the part, but not so much that it burns it. But what ends up happening is that because of that fine line between, you know, how much time it takes to expose it to make the part, you know, what you'll get at the end is a part that still needs a little more exposure to UV light, and it needs to be washed off. Now, most of these resins, the part that you get out of them needs to be washed in an alcohol bath. But there's new resin out there that will allow you to wash it off in water. And I'm not talking about like going and washing it under the sink, because the other thing to keep in mind here, you know, there's a lot of trade-offs to get that level of detail. You know, FDM printers, nice, easy. You squeeze the plastic through the nozzle, you lay it on the bed, you watch the part get made over time, you take it off, you can use it right away. With these, there's liquid in a little vat that's open, you know. I mean, the vat is open. So you could accidentally spill this stuff. The resin that you're putting in there, the resin is toxic. So you don't want to get it on your hands. You don't want to be smelling the fumes. Thankfully, most of the resins that are being produced these days, most of the newer resins, you know, old formulas still stink like hell. But the newer resins don't stink as bad anymore, right? So you got to wear nitrile gloves. You can't wear latex because the resin will burn through latex. You can't wear vinyl because it'll jack up vinyl. You have to wear nitrile gloves. And, you know, you have to be careful as you're removing the print, because the print will still have like wet, uncured resin on it. You know, so after the print is done, you want it to kind of leave it there so it can drip, you know, and get some of that out of there. But some of the prints that are hollow, as you're removing them from the bed, they're going to have resin inside of them. So you want to be careful as you're tipping the bed over, you know, because with the SLA printers, the prints print upside down, you know, so they build the bottom layer first, but the bed starts raising up. Where these, you know, it builds it from the bottom to the top. These build from the bottom to the top too, but the whole bed is upside down, getting dipped down into the resin and building one layer on top of the other. But the print will come out, you know, upside down. So if you flip it over, you'll have a lot of resin in there, maybe, depending on how the model was built. So you got to have a lot more care and a lot more patience with these, so you don't get the resin all over yourself. You don't get the resin all over the table. You don't get the resin all over the animals. And because it's toxic, we don't want to wash that resin down the sink, because we all know that most of our sewage water, you know, goes into places where there might be animals that could drink it or whatever. I mean, we don't want that water. We don't want to put toxic resin into our water systems, right? So you shouldn't be like washing it off in the sink. So anyway, yes, there is water washable resin now, where you can just use plain water, or you can use the standard resin, which takes alcohol to wash all of the uncured resin off of the part, right? So there's the post-processing involved. And then after you wash it off, you need to expose it to UV light. But you need to expose it to UV light evenly, which means that you need to have the part sitting on a turntable, right? So there's like a UV light, maybe a UV light on two sides of a box, and you've got it spinning around inside of a turntable. Now what I've got is, and it's another box that looks almost identical to this one, called the Anycubic Wash and Cure 2.0. And the Anycubic Wash and Cure, it has a washing basin with an impeller in the bottom that spins around, and I just fill it up with water, right? Run that, and it washes the print for me. You can set a timer, 3, 4, 5 minutes, walk away, and it's every bit as effective as using like an ultrasonic sink or something like that. And after you're done with the washing portion, you dry off the object, because now you've got all of that uncured liquid resin off of it. You dry off the water, and then you put it back into the same box, and it's got a turntable in the bottom with a reflective surface, and it's got UV lights that shine on it from different directions, and it spins it around for like 5 to 10 minutes, whatever you set the timer to. And that will cure the print the rest of the way. So it doesn't come out fully cured. You still have to expose it to more UV light. And that's where these things get a little tricky. So, it takes some dedication and some know-how, and there is a learning curve to both processes. Where this one takes a little more time on the front end, to make sure that the printer is set up correctly, that it's calibrated right. These are much easier to set up because, the only thing that you really need to do is level the bed, which means just lower it in there, tighten up a few screws, and you're done, right? Leveling the bed on an SLA printer is infinitely easier than leveling the bed and calibrating an FDM printer. So, for all of the heartache and pain that it takes to calibrate an FDM printer to get awesome results, that all comes on the backside of the post-processing that is required of an SLA printer. But they both have their applications. They're both phenomenal. And, for anybody that's interested in really customizing their airplanes, their RC cars, I highly recommend getting one of each. Start with an FDM. The FDM is going to be able to get you some pretty practical stuff, like the nose wheel braces that we use on our airplanes. They, you can make those with FDM printers all day. They work great. I made one for Reitza. He's got one. I think it's still working well for his T28. I've got a couple of parts that I've designed. I've got a couple of camera mounting brackets or their eye-cup mounting brackets that I made for Jeff in Lower Alabama and Sea Mafia. And I'm going to be sending those out to them hopefully Wednesday or Thursday this week. So you guys, if you're still in the chat, we're going to get those camera mounts for the eye-cup for your Sony AX53 sent out to you. And those things are awesome. And they're great for those kinds of pieces, like utilitarian pieces. But when you really want that fine detail, when you want like an instrument panel where you can read the numbers and the gauges, you can really see like every fine detail of the print. Man, that's where the SLAs come into play. These things will blow your mind. The parts that come out of SLA printers, especially now that we're getting into the mono screens, like I think the Elegoo Mars that Noons has is still a 1080p screen, and it's a color screen if I remember correctly. So you have to get like the Elegoo Mars 2, I think, is where they switched over to the mono 2K screen, which has, faster cure times per layer and a monochromatic screen instead of color. So it allows more of the UV light through. The color screen versions, the 1080p color screen, LCD panels don't let as much light through, so it's a longer cure time, about 6 seconds cure time. Where these can expose and cure each layer in about 1.5 seconds to 2 seconds. So, about 3 times faster. But you have to lift the bed up higher for each layer and then set it back down. So, like the time that you save by getting 3 times faster exposure rates is negated by how much higher it has to lift the bed up per layer. So, there's a trade-off that you end up saving like 20% of the time. It's not like you're not saving that much time. So Bobby K, his girlfriend's birthday was this past weekend, and he was with her. JT200, that's funny. No, we're not going to be 3D printing any OpenTX transmitters. Although that would be sweet. They should be open source. I should be able to like print the whole body. Yeah, so I saw a question from Mickey B. I'm going to try to back up and get back to that. So Mickey B asks, once you have both startup costs, all components on both printers, what is the price difference between standard materials, PLA versus resin, for ongoing costs, right? So, so let's talk about the startup costs, right? Like, how much does it cost for me to get into an FDM printer? And we're going to talk about, like, the time associated with it. Learning curves, calibration, you know, if you really dedicate yourself, and how much do you value that time? How long does it take to start getting fantastic prints out of an FDM printer? So, as most folks here can attest to that have FDM printers, yep, you know it, Gooniac. So most of the folks that have FDM printers, you know that when you get these things out of the box, if you just try printing, if it doesn't have auto bed leveling and all of those really fancy cool features, if you go with like a budget-minded 3D printer, you're not going to have all those cool features. So trying to get awesome prints off of an FDM printer, the first print is almost always going to be jacked up. It's almost always going to be jacked up, right? And that's okay, you know, because it takes time to calibrate it. It takes time to learn what's going on and all the different moving parts and what the belt tensions need to be, etc., etc. You don't have any of that crap going on over here. So, you know, yes, there's a learning curve. You can pick up a printer just like this one. You know, it's got different fans. I've done a lot of silly upgrades that aren't like 100% necessary, but they do increase the performance of the printer. But in this particular case, this printer, you can pick up one right now for about $250-ish. And the printer, and probably about $20 per roll of filament, that's all you need to get started. That's all you need. And, you know, with that being the case, because you can buy the printer and you can buy the filament and you're basically have everything that you need to get started, right? That's the end of your startup cost, right? $250 plus another $20 roll of filament, $270, you're in. Wrong. That's where the learning begins. Now you got to learn how to use the slicer. You got to learn how to bring in, you know, your print files. You know, so the print files are what we call STLs. You know, you'll see in a lot of the, you know, 3D printing forums or whatever, Facebook groups, people are always asking for STLs. The STL is the file, the 3D model that we will import into a slicer. You know, so for FDM printers, there's 3 really popular slicers out there. 2 of them are free, 1 of them not so much. You know, we can talk a little bit about those as well. So you got Cura, you've got Slicer, which is like, it's SLIC 3R, you know, so they did like the backwards 3. Sorry. RC Glory, what is going on? Thanks for stopping by tonight. So yeah, you've got Slicer, you've got Cura, which is very popular. Slicer and Cura are very popular. In fact, like Prusa, who makes one of the better, manufactures one of the better FDM 3D printers out there, but it's kind of small, very expensive, about $800, all in for like a Prusa Mark III. They're very expensive, but they're awesome. So those printers, they use a variant, like their own, variant of the slicer software. They call it Prusa Slicer, but it'll work on any printer. So yeah, Slicer, Cura, and a third one, which is not free, you have to pay for it, called Simplify 3D. Now, I am a glutton for punishment, and I love throwing my money at people that make my life easy. So I bought Simplify 3D. I bought it years ago. The problem with Simplify 3D is that years ago, when I paid to get Simplify 3D, they've done like one update to the software since I paid for it, and not another update since. And it's like, wow. They just took my money and ran. I mean, they're still active. So you can see that there's still, people there. They still respond. Their forums are active. There's employees that are answering questions. And they were supposed to come out with like a 5.0 version like a year ago. Never saw it. There's been no updates to Simplify 3D for a long time. So, I mean, at this point right now, just based on that, I would recommend like getting Cura and figuring out how to work around some of the limitations. Like the Simplify 3D is way better software. And even though it hasn't been updated, I mean, sometimes it's better to leave good enough alone. Simplify 3D is amazing. The supports are much easier to get off of the prints. You can set up different workflows. You can change settings mid-print. Like if you need to, not just for temperature towers. I mean, we can slow things down, speed things up. There's a lot of transitional things that we can do. We can have one model that's printing at one rate and another model printing at another rate. We can change rates right in the center. There's things that Simplify 3D can do where we can have multi-process print jobs that like Cura and Slicer cannot do. But if you're not getting into like super, geeky stuff like that, then Cura is going to work for 99% of users. So I would use that. Free Slicer, works great, lasts long time, pay no money, be good. The Slicer for the SLA printers, there's two main ones right now. One of them is called Chitubox. I mean, that's not really 100% true. For these particular printers, for the Anycubic Photons, they've got their own version of a Slicer program called like Photon Studio or something like that. Not Captain Photon, the Anycubic Photon. So they've got their own slicer, for the Photon series of printers. But I still use, either the Chitubox, which is CHITU box, Chitubox, and there's another one called Lychee Slicer. The slicing, obviously, with the much finer details and much finer resolutions of SLA, you can't use an FDM slicer to slice your SLA 3D print. They don't work. So, and the file formats are different, so this one expects to see G-code, and a lot of the files that get output for SLA printers are proprietary to the manufacturer, but the Chitubox software and the Lychee Slicer software will output in the correct format for the printer that you're using. What is up? So I see there's a lot of folks coming in that are, probably in the same basket there with BD Tennessee, who's watching the Final Four tournament. If I liked basketball, I would probably be doing the same, and I would have told y'all to pack sand for the night because I'm watching basketball. But I don't really watch basketball, so it's all good. So George Watts, I mean, that's a good question. George Watts asks, for those of us that are printing parts on 3D printers, are we printing items that can't be purchased already? So I'll tell you, a lot of the stuff that I have printed for airplanes is either stuff that is not available as a part that you can buy. It's only available as a model file. So, you know, like the company will provide an STL, and if you want it, you can 3D print it your damn self, but they're never going to make it, right? So it's not worth their while to make a mold for the 40 people that want this particular part. But they will provide like they've designed it, and they could make a mold, but they're never going to sell enough for the mold to pay for itself. So they'll provide the STL file for us to print it on our own. A good example of that is a lot of the cockpit components, pilots, ejection seats, ordnance, things like that for a lot of the free wing and flight line models. So Alpha will create, the cockpit components, or other users will create the cockpit components, and Motion RC will put those STL files available for download where we can go grab them and print those parts. So I think a lot of people are doing that. If you are an enterprising type of soul and you like to fart around with 3D design, there is a lot of things that I have designed out of necessity that are not available. An example of that would be the iCup holder that I made for my camera. I mean, I designed that thing from thin air, just using 3D CAD software, and it works well, for my camera. Is it going to work for anyone else's? No, but my model of camera with that model of eyepiece, it was like a one-off deal. Met him, that'd be awesome. If I could make a 3D eardrum, it would work a lot better. Actually, my hearing in this ear is starting to not be so bad anymore. It doesn't sound like I'm underwater anymore. And it could just be from, that I'm just getting used to it, so I don't care. Or it's actually healing, which is awesome. So Michael Bear, I've been trying to... I didn't eat any gas producing foods tonight, so hopefully we'll be all right. So the other thing that I like about 3D printing, especially when you have both options available to you, is there are a lot of parts out there that, while they may be readily available, it's just not cost effective. So say like a pitot tube, for example. I don't want to pay $5 for a pitot tube and $5 to ship it and pay $10 for a pitot tube. I could just print a new pitot tube. And with an SLA printer, I mean, the nice thing too about SLA printers over FDM is FDM, things kind of have to be squared up on the build plate, in order for things to work right. With an FDM printer, I can angle it. So even though I've only got like a 6x6 surface, I can angle it so I can get like a 9-inch, if everything is at the right angles, you can get like a 9-inch pitot tube out of the thing if you want it. I mean, you can set it up at different angles. You can do all kinds of weird stuff, which a lot of times can actually make the resolution of the print even better. If you run it at an angle instead of running it, like straight squared up, prints that are squared up in a resin printer don't don't typically have the the appeal that you would want, and it's harder for the resin to run off, so a lot of times when you're printing on a resin printer, you'll print it at a bit of an angle, like 30, 40, 45 degree angle, and the resin can easily, like drip off of it during the print process. There's a lot of benefits to using, kind of a cant, like a cant angle as you're printing it and it's coming up off the bed. So, that's another thing that I like doing with them. Little antennas, that break off. What a pain in the butt. Like I still want the antenna, but I don't want to buy like an entire tree of plastic parts just to get one antenna. So I'll just make it, It makes things, it makes things easier depending on how you look at it, right? Yeah, Roberto, I have seen some folks. I have a 3D printed Spitfire that I never flew, and unfortunately, since we've been here, some components of it have been broken, and I would have to 3D print them again. And what a drag, so I've just kind of abandoned that project. But I have seen a 3D printed plane crash in person, and it was freaking spectacular. It was awesome. I mean, it just exploded. Jermaine Spencer, just make time. Just get out there. Get out there and maiden that thing. Do it. Just fight in the neighborhood. So yeah, I mean, like there's some folks mentioning there are also 3D printed airplanes out there. There's actually more folks getting into the game. One of the first ones to really hit the scene was 3D Lab Prints, who has some phenomenal 3D printed airplanes, big stuff. There's been a few more folks to enter the 3D printed airplane design game since then that you can just buy the STL files, so usually they'll sell the STL files, and there's a lot of them for an airplane. You can buy those STL files for, $30-40, and then buy all the materials. So to print all of the materials for a 1600 millimeter Spitfire airframe, I think it used five or six spools of filament. I mean, it takes a lot of filament, right? So that's like $100-ish worth of filament. If you buy in bulk, you can get it cheaper, so I think I paid about $100 for all the filament that I needed, plus the $50. So $150 for a 1600 millimeter, and we're talking like spot on scale. It's not like it's not like a foam model. Can you get scale details from a foam model? Of course you can. But these 3D printed models, I mean, they are next level. Especially when you sand them out, you get them nice and smooth, like you do all of the surface sanding and all that stuff. But you can get some amazing scale realism from these 3D printed airplanes. They're fantastic. The problem with them is, they have to be light, so you're printing them very thin. If you print like double layer walls, I mean, they're single layer print walls. If you crash it, it's gonna destroy itself. They are not tough, but they're very airworthy. So they fly fantastic. I mean, they've got very realistic airfoils, very light wing loading for their sizes. You know, they're not as heavy as you would imagine at all because they're mostly hollow. It's just a very thin, skin. You know, and usually that skin is maybe 0.5 millimeter thick. I mean, we're talking tiny, tiny stuff here. So, when you're talking single layer wall thickness, I mean, that it's just a membrane, but the supporting materials and the way that they have the supporting stuff on the inside of that hollow print, keep all of that from crushing under the weight of the wind blowing across, and just the pressures of flight. So they perform really well. And they look fantastic, but good God, you wreck it, man. They're done. John Graham, I don't see why you couldn't. The problem with the ones that I've seen, right, is they have the servos inside the electronics cavity. If you were to move the servos back to the back of the airframe, obviously your aileron and flap servos would be in the wings. But your elevator and rudder servos are typically in the electronic cavity. If you move those back to the back of the plane, I don't see why you couldn't fill it up with foam. Like the spray expanding foam, just spray it in there from the back and lift it out. And that would absolutely make it much more, that would give it much more structure and strength with negligible weight gain. So that's not a bad idea. Yeah, you could do that. Jet Tech Don Adkins, what is up? So Dennis Farley keeping the peace up in here. Dora Blevins, it's good to see you. Man. Joe Habib, what's up, man? Joe Pellegrino, hello, sir. All right. So, I've been talking about these things for a while. Does anybody, and unfortunately when I go on a roll, man, you guys know how it is. I'll just go on a tangent and I'm just looking at the camera and I'm not paying attention to the chat, which is terrible. Shame on me. But I want to sit here and look at the chat now and answer any questions that you guys may have about 3D printing, what types of things, different applications that we can use for 3D printers. I can answer them. We've got plenty of people in the chat tonight that have 3D printers that can tell you about how they work and all that good stuff. But I just wanted to give kind of that synopsis, the difference between FDM, SLA, which one is going to be better suited for the types of things that you're wanting to make and all that good stuff. Read the teleprompter. I don't have a teleprompter. I just go. The material that is wasted from bad prints. David Martin Graff, a lot of times, for me, if it is FDM, I will throw it in the trash. I just take the bad, like leftover support material. If I have a bad print, I've just got a big spaghetti incident sitting on the print bed. I'll just take it and throw it in the trash. With the SLA stuff, because it comes out not fully cured yet, all of the junk, you want to expose it to UV light to fully cure it first. And once it's fully cured, then you can throw it away safely. There's not really any benefit to melting it down. I have seen some folks that claim, I think there's like a filament extruder that you can buy if you're just really that interested in saving money, right? Where you can take, like, say you have a big old box and you just take all of your bad prints and your, supports and stuff from PLA, and you're always using like the same brand of PLA. And most PLAs, I'm sure once you melt them together, will kind of fuse and form some kind of usable plastic. I have seen, other reviewers, people that do 3D printing reviews all the time. These machines are thousands of dollars, but you can take like all of that junk, PLA, and throw it into like a hopper, and it will melt it down and start spitting out, 1.75 usable PLA, but now it's all different colors, right? So if you have like black and white and purple and green and the colors don't really blend together. So you've got like this crazy multicolored, swirly filament coming out of there, and you can recycle your filament. For me, it's totally not worth the hassle of buying one of those machines. But if I was running like a big print farm and I had hundreds and hundreds of pounds of, garbage filament from bad prints or whatever the case may be, I would probably be interested in doing something like that. But under the current circumstances where I just have one printer, and I'm only throwing away like a few supports here and there, I'm not interested in doing all that. So Joe Pellegrino asks, am I able to print TPU through my printer, and if so, what extruder is being used, and is it Bowden fed? So Joe Pellegrino, this is a Bowden printer. I do have TPU, but it is not a good, it's not a very Bowden friendly TPU that I'm using. So even with, I can't remember who makes this. This is an EZR extruder. It's a great extruder, and it feeds like ABS, it feeds PLA, it feeds, any of the more rigid filaments with no issues at all. The TPU, it'll get it through the tube, but it starts to back up. Like the tube, I don't know if I need an all metal hot end or something. There's something going on where, it'll extrude and push the filament for like maybe the first layer, and it looks like everything's going well, and then it just turns to crap. Just bleh. And the nozzle gets clogged, and I think it's a combination of, the fact that I'm using a Bowden tube, I'm not using an all metal hot end, the brass nozzle that I've got on there, I've had there, I've never changed it, so there's probably some imperfections in the brass nozzle that are causing some problems. But I've tried fully going through this thing. I put a new nozzle on it. It still doesn't work very well for me for printing TPU, at least the TPU that I have. There is there is TPU out there that is a stiffer compound, and it's sold under the brand Ninja Flex. And apparently that TPU works very well in Bowden tube printers. But this one, the TPU that I have is not Ninja Flex, and this printer can't print that TPU worth a darn. Direct drive printers, my understanding is that most direct drive printers can print any kind of TPU, no problem. Yeah, the Bondtech extruders are awesome. Do you have the Joe Pellegrino? Is your Bondtech like actually mounted, right to the hot end? Is it like a true direct drive, or are you just using a Bondtech with a Bowden tube? So I want to say, if my memory serves me correctly, that the Bond tube or the Bondtech extruders, don't they have like a geared system, like almost like a reduction gear? So, John Graham, it's no more complicated than programming, a transmitter. I mean, all things technical sound much more complicated than they really are, and 3D printing is absolutely one of those things where the tech talk can be intimidating. So a lot of people stay away from it. They're like, that sounds way too difficult. And even to me, I was like, I don't want to mess with all that. But I'm glad that I went ahead and got one, because I learned pretty quickly that it's really just learning the terminology. And once you know the terminology, using the printer itself is really easy. Yeah, Joe Pellegrino, that's weird. My understanding was those Bondtech extruders, man, those things are supposed to be awesome. Where they've got those reduction gears in them. So instead of, I think you have to turn up your stepper, you have to adjust your steps per, you have to calibrate your stepper motor for your extruder. Does that sound right? Yeah. So you have to calibrate the extruder stepper, because it has to do like 3 times more steps to spit out the same amount of filament that it did when you were still using TPU. So is that something that you've done already? Have you calibrated your stepper for your extruder since you switched over to the Bondtech? Yeah, extruder stepper, man. It like blows my mind. It's one of those words that phrase just doesn't roll off the tongue, Yeah, the Volcano hot ends are supposed to be great. And I've looked at doing the same thing, like the Volcano hot end with the Bondtech extruder, because they make like a whole big bracket that you can, on the Ender 3s, you can do a Bondtech with the Volcano hot end. And it's awesome. It's all kind of like just one deal. But it prints so good right now, Like, the only benefit that I get from doing that is the ability to print TPU. And although I would love to be able to print TPU, and I can think of a lot of different things that I could do with the capability of being able to print in TPU, like that expense, I'm just not, I don't want to do that right now. So Joe Pellegrino, that is where I would start with your TPU issues. Is I would start with recalibrating the extruder steps for the Bondtech extruder, because the like the stock extruder calibration, the stock steps to extrude, say, 100 millimeters of filament is drastically different than if you were using the Bondtech extruder. I think it's 3-to-1. You know, so for every turn of the stepper motor, you know, and however much you get, it takes 3 turns of the stepper motor to get that much filament out of a Bondtech. So something to think about. Lyndon Stewart, hello, sir. Welcome to the show. Yeah, and I've thought about doing the direct drive conversion, you know, using the same extruder that I have now, and basically you're just moving all of the stock extruder and stepper motor to sit right above the, you know, the stock hot end. I've thought about doing that, and I think that it would work well. In fact, I think you can print that kit, you know, if you've got all the wherewithal to print that stuff out. I think you can print those parts and make your own conversion kit. In fact, you know, a lot of folks that have FDM printers, you know, like the first, you know, week or two of your ownership will be printing out like upgrade parts for your printer, which seems like I just bought a 3D printer, so why would I print off a bunch of parts? Well, you know, like this big contraption, that's not part of the print. I printed that. It's called like a Pet's Fang, you know, air cooler, which takes, you know, the air from this blower fan and it blows it into here, into like this plenum. So I get, you know, an equal amount of airflow going around both sides of the nozzle as the filament is coming out. So I get much better part cooling, and I can run the fan at like 50% instead of 100% and still get really awesome results. You know, there's all kinds of little things in here, little cable reliefs, and you know, the cable chain on the back to keep things from, you know, from getting all tangled up. There's like a little box down here that you guys can't see that holds like little tools and stuff. There's a little fan shroud, you know, here where on the top of the Ender 3, the fan was exposed. So I put this little fan shroud on there that prevents, you know, pieces of filament from going down into the fan and onto the control board. So like the first, you know, few days of ownership, you're going to be spending a lot of time just printing goodies to go on your printer, which is fun. Oh, Joe Pellegrino, this thing is awesome. It's awesome. I mean, like, I love this thing. But it's also my first SLA printer, right? So when you've been using FDM for years, and then you finally see what these things can do, I probably could have bought like the cheapest piece of crap SLA printer out there, and I would have been so blown away impressed with the quality of the print that came out of it. But this one is, you know, it's not the cheapest on the market. I picked this up for like $213, $220 maybe. Anyway, somewhere around there, about $220. They list on Amazon right now between $250 and $270. There was a guy on there that was selling it brand new for like $230, and he had a 13% off coupon box. You know, the little click this coupon and get another 13% off. So That's what I did. Excuse me. So that's what I did. I got it for like $230 plus a 13% off coupon code, which, I mean, I couldn't beat the price. It was actually less than the Elegoo Mars, the original Mars printer. So for the mono, the Anycubic Photon Mono that has the 2K monochrome LCD panel, you know, faster printing, all that good stuff. I mean, I couldn't beat it. It was a no-brainer. Lyndon Stewart, it is. That is the Freewing 90mm f/18 in the Blue Angel scheme. Thank you, Jermaine. Yeah, and you're right, though. Like, printing all the parts for your FDM printer, that's a great way to learn, you know, how the slicing software works, you know, getting the calibration just right, all of the stuff that you need to learn to really take advantage of your printer. You know, that's where I learned that my gantry wasn't straight. It was a little bit tilted, so the gantry was like going up a little bit on one side, and I was like, man, what the heck is going on? So I printed these little deals where I could get both sides of the gantry perfect. And now I'm a lot happier with the performance of the printer. You know, like as the bed goes, or the gantry goes up and down, this side's not like lagging in one direction or the other, which was a problem when I first got it. So I'm really happy with the performance of this thing now. This thing is awesome, and has been awesome for years. But it does take a little bit of finesse to get it going the right way. So, you know, that's one of those things where I'm, man, I'll tell you, I have had my hand like this close to the buy button on one of those Prusa i3 Mark IIIs for a long time. And then I keep coming back to this thing, and I'm like, what can that do that mine can't? You know, so I've got like the Easy ABL from TH3D Studios. The Easy ABL is like a capacitive bed leveling, you know, auto bed leveling device, which works very similar to the Pentaprobes on the Prusas. I mean, the Prusa's direct drive, which is really nice. I'd love to have it direct drive. You know, but there's conversion kits where I can make this direct drive. I mean, I've done so much to this Ender 3 that I believe that it performs at the level of a Prusa now. It took a ton of work to get it where it's at. And if I were to do it all over again, like if I wanted a second printer that was this size, I would get a Prusa all day long and be like, I'm not messing with all that crap. I'm getting the Prusa and I'm going to be done with it. It's going to have all the stuff that I want and I'm just going to be done with it. But, you know, now that I've gone through the process of upgrading this one and making it where it does all of the cool stuff that the Prusas can do, it's like, you know. So if I ever feel the need to have two, I'll probably go Prusa for the next printer that I buy. Joe Pellegrino, $179.99 for what? You talking $179.99 for the Anycubic Photon? So the Anycubic Photon might be $179.99. And it looks almost identical to what we've got sitting here. This is the Anycubic Photon Mono, which should be more expensive. But if they are $179, I'm buying another one. Yeah, the Anycubic Photon Mono should be a higher price. But I'm going to look it up. Because why not, man?
Playing from damned O2.
Oh my God, lady. Alright, here's the Anycubic Photon Mono on Amazon. It's $229. Here's another one that's $229. Wait, that's the same one. $259 with the coupon. The wash and cure station is $179. Yeah, so I don't remember exactly where I got mine, but yeah, I mean, the price that I'm seeing for them is right around that $230 price point for the Anycubic Photon Mono. And the Anycubic Photon Mono has a little bit better print resolution, right? It's got a 2K screen instead of a 1080p screen, so you get finer pixel density. I think the pixels are 4 microns. I mean, they're tiny. So you get much better pixel density out of the Anycubic Photon Mono. But, you know, like I've said, when you get to the level of detail that these things have, the only time that you notice that is when you're like right on it. I mean, you need a magnifying glass to see the imperfections in some of the prints that come off of an SLA resin printer. I mean, you dang near... can't tell the difference between some of the parts that come off of these things and an injection molded part that came out of a nice, milled mold. George Watts, thank you, sir. Yeah, right? Yeah, so, if any of you guys are looking for a 3D printer or you're wanting to try one, I would always recommend going with an FDM printer first, unless you are looking to create like little tiny miniatures, little miniature figures, statues, trinkets, then maybe look at an SLA printer first. But I would always get your feet wet in the world of 3D printing with an FDM printer, something like the Ender 3. The Ender 3 is very cost effective. Even the original Ender 3 is still a great printer. By today's standards, I would get the Ender 3 V2, which I think runs around $250. Get you a couple of rolls of filament, whatever colors you want. I would personally start with PLA when you're learning. The PLA is a far more forgiving material. It's easier to print with. It's easier to get it to adhere to the bed. The learning curve is not quite as steep, and learn the ropes, and I think that what you'll find is that the 3D printing community, for the most part, is almost as friendly as RC people. They're almost as friendly as RC people, but you're gonna find dicks everywhere, right? Hey, Gooniac, man, that's not a bad idea. So Lyndon Stewart is asking, and we got 8 minutes left, so We're about ready. So Lyndon Stewart is asking, which would be the best EDF jet you would recommend for a beginner who never flew an EDF before? So if you've never flown an EDF, have you ever flown any high performance prop planes, any high performance warbirds, like P-47s, P-51s, any kind of low wing sport plane that got up into that 70, 80 mile an hour range, and if so, how did you handle it? Did it seem like it was too much? Or are you flying them and you have no problems with them? $7:02 Pacific. All right. So I will try to jump off of here at 10 o'clock Eastern, right on the dot. So B-26, a B-26 is not going to behave like an EDF jet. So a lot of folks are recommending the Habu, which is a great choice. The Habu is set up more like a trainer. So it's got a very wide speed envelope, and you can run it on 3S and 4S packs, which makes it fantastic. So the E-Flight Habu, that's a good recommendation for somebody getting into EDFs. It does not have flaps or gears, so it's a standard straight up 4-channel type of setup. You can make it fly very stable. But on 4S, it'll move, so you can get a very good taste for what EDF performance is going to be like. The only thing I don't like about the Habu as and sorry, I'm like looking off camera. I'm staring at a Habu right now. So the only thing that I won't even say that I don't like it about the Habu, but the speed envelope of the Habu is almost too wide. You can slow them way down to speeds that are unrealistic for other EDFs, but it makes for a great trainer, to get your feet wet with EDFs. So with 3S, you can kind of get the Habu into a high alpha situation. You can just creep along, which is not something that you would be able to do with other EDFs out there. So, what I would hate to do is recommend a Habu to you, and you get used to kind of the slow flight characteristics of the Habu and think that you can do that with any EDF. The Habu has aerodynamic characteristics that prevent it from stalling. Will it stall? Sure it will. All planes will eventually stall and fall out of the sky, but the stall speed of the Habu is much slower than a lot of other jets. So, that's the only reason that I would kind of steer away from that one for someone that has experience with other faster airplanes. The E-Flight Viper is a fantastic flying EDF. It's 70 millimeter 6S powered, so you need like a 6S 3200 to 4000 is about as big as I would go in a Viper. The E-Flight F-16 is not a bad choice as a first EDF. If you're willing to, go ahead and step up to 6S batteries now, some people have mentioned the Aeros RC of, what is that thing called? The little Aeros one. The Marlin, yes. So the Marlin would be a fantastic choice as the first EDF. It's a 64 millimeter, but it's got flaps, rudder, ailerons. The only thing it's missing is your landing gear, so you don't have retracts. I I wouldn't really go with like the Dyna Meteor. I don't know that that's a good choice as a first EDF because it handles kind of funny. At least to me. I mean, if you're willing to take the 6S plunge right off the bat and you want to, just get like a universal battery size, I mean, some people don't like it, but I will always recommend the Freewing Avanti S. I think the Freewing Avanti S has such a forgiving speed envelope that if you're not comfortable with how fast it goes, you can slow it down and really tame it out and get great flight durations, and it handles true, so it doesn't have any bad tendencies. The Freewing Avanti is just an amazing airframe, and the FMS Avanti, I mean, it's the same airframe, so it also handles amazing, but it's also 6S. It just uses a more uncommon pack size, so because it's a 70 millimeter, you're looking at like 3,200, 4,000 batteries. Where, typically when you get into the 6S, I think like the universal 6S size battery that I like is a 6S 5000. So I tend to recommend planes, when folks are looking at 6S airplanes, I'm going to recommend planes that use a 5000 pack because I like the idea of having, packs that I can use in more than one airplane. If I have an airplane and the only packs, like I have to buy packs just for that airplane, that upsets me. So most of the airplanes that I have either run on 3S or 4S 2200s, 3S or 4S 3200s, or 6S 5000s. What is up, Spencer? So listen, guys, Guniac has a premiere coming up in like 2 minutes, so we are going to go ahead and cut this stream off. But I appreciate everybody coming out. Be sure to visit rcairmarshal.com and check out all of our affiliate partners. All of the links on there, if you use those links to buy different things, from Horizon Hobby, from BitGo Hobby, from Amazon, from Banggood, from our Teespring store, or you want to make a donation via PayPal, you can click the link at rcairmarshal.com and make a donation to the RC Air Marshal or buy anything from any of those affiliates, and it will offer a small commission back to the channel where you can support the RC Air Marshal YouTube channel, and we will love you for it forever. The Amazon link, when you go there, it has like a store that's got like some batteries and some soldering equipment and stuff like that. Don't worry about that. You don't have to buy something from that store. If you click that link and then go up to Amazon, search for whatever, it still helps us out, right? You don't have to buy something that I have in my little Amazon store, which needs to be updated. But anyway, we're going to get going. Ray, thank you so much. You're awesome, dude, and I will be in your show. Ray has his live stream coming up in 15 minutes. Be sure to stay tuned for that, and he has a premiere in like 2 minutes. So everybody go and do whatever you do for the next 2 minutes, and be sure to tune in to Ray's premiere here in 2 minutes, and be sure to tune in to all of our buddies throughout the week in one of the greatest communities that I could ever ask to be a part of. I love you guys. Thank you for coming out. We will see you all next week. Happy flying, guys.